Hi everyone. Today we'll be discussing the LeetCode problem of the day, count special triplets. So here you are given an integer array nums, and a special triplet is defined as a triplet of integers I, j, k, such that I is less than j and j is less than k, where n is a number length of the array. Like suppose we have three triplets I, j, and k. So he says that uh, nums of I must be twice of nums of j. So suppose if nums of j is x, then nums of I should be 2x. And similarly, nums of k should be twice of nums of j. So if j is x, then k should also be twice of x. So if we have any triplet which is following this property x, 2x, and 2x, then it's a special triplet. So you just have to return the total number of special triplets in the array. And since the answer can be large, you have to return the answer after taking modulo with this number. So let's see the first input. So the array is 3, 6, and 3. So in this array, we only have one triplet, which is of index 0, 1, and 2. And the values are 6, 3, and 6. This triplet 0, 1, and 2 is a valid triplet because we can see that if this is x, then nums of I is 2x and nums of k is also 2x. So this is following this property. So this triplet is a valid special triplet. So the output is 1. Now if we look at the second input, we have the array as 0, 1, 0, 0. The indexes are 0, 1, 2, 3. In this case, the only triplet which is following this property is 0, 2, and 3. So these are the indexes. And the values is 0, 0, 0. This is also following this property because we can see that if this is x, then nums of I is twice of x. And nums of k is also twice of 0. So this is following the property. So 0, 2, and 3 is a valid triplet. And in this example, we can see that no other triplet can will satisfy this criteria. So for this case as well, the output is 1. And also now coming to the constraints, the array size can be up to 10 power 5 and each element in the array can be from 0 to 10 power 5. Now let's go over the approach. So to solve this, we can think of a brute force approach where we'll run a for loop. The first loop is for I, and we'll run a second loop which will run on the j, and third loop which will run on the k. So we have three loops. One is for I, j, and k. And in this, in the inside loop, we'll just check the condition that if nums of I equal to nums of j into 2 and nums of k equal to of k to 2. So inside all these three loops, we'll just check this condition, and if the condition is true, we'll just increment the answer. So this is the simple brute force. We are iterating on all possible triplets and counting the answer based on the condition. So by doing this, we will have a complexity of order of n cube because we are running three loops. And since we have n as 10 power 5, so this approach will fail. So we now have a algorithm with complexity order of n cube. So now let's try to reduce it to n square. Even though n square will fail, but let's see how we can reduce it to n square. And further, we will try to reduce it to order of n. And this is the desired solution, which will pass based on the given test case. So the brute force is n cube. Now let's think of the question in a different approach. So we have three triplets, I, J, and K. So instead of iterating on all the triplets, what if I'll iterate on only the middle one? That means I'll fix the J. So for a particular J, I'll try to find how many triplets are there, how many triplets are forming with I and K. That means suppose my J is here, J is fixed. So now to form a triplet, I want to search I in this range from 0 to j minus 1. So I'll find my I in this range and I have to find my k in this range. So since my number is 2, all I have to do is I'll iterate on the left part and count how many occurrences of 4 is present. 4 because it's 2 into 2. Because we want to find the number which is 2 times of nums of j. So for a particular j, I'll iterate on the left part and count how many uh, occurrences of 4 are there. So in the left part, only one occurrence of 4 is there. And in the right part, I'll again iterate separately and count how many occurrences of 4 is there. So we have 2 occurrences of 4 in the right part. Now to find the total triplets having j as this point, we get it by just multiplying this left part and right part, which is 2 triplets. So triplets is this 4, this 2, and this 4. And the other triplet is this 4, 2, and this 4. So for each particular j, we are just iterating on this and this. So for a particular j, the complexity is order of n. And since we have n number of j center values in this array, so the total complexity of this approach will be order of n square. So like we saw, if we fix the center and we try to get the number of triplets, we reduce our complexity from order of n cube to order of n square. But although this is n square, it will still fail because like n is 10 power 5, so n square will be 10 power 10. So now let's see how we can reduce this further to make it order of n. So for that, let me just again. Yeah. For this, we'll follow the previous approach only. We have I, j, and k. In this also, we will fix the middle point. Suppose my j is at this point. So at this point, all I need to know is how many occurrences of 4 is present in the left part and how many occurrences of 4 is present in the right part. Before, what we were doing is we were iterating on this entire array, entire left part, and manually counting how many 4s are there. So instead of doing it, what if there is a hash map which stores the occurrences of all the left part of the array? So let's say this is a left hash map. So if I draw it, it will be something like this. 6 is the key and it is present one time. 1 is the key, it is present once. 4 is present once. And 3 is present once. And similarly, for the right part also, let's say we have a hash map. So this hash map will have 6 is the key and it is present 2 times. And 4 is the key, it is also present 2 times. So for a particular j, to get the left count, all I have to do is look in the hash map, the frequency of the 4. So in constant time, we got to know that one occurrence of 4 is present in the left part. And for the right part, we'll look in the right hash map and see the frequency of 4 in constant time. So here it is 2. So there are 2 occurrences of 4 in the right part. Now to get the number of triplets, we'll simply multiply 1 and 2, which is 2 triplets. So like we saw, for a particular j, to get the left part and the right part, the complexity is order of 1. And since we have n number of middle values, the total complexity of this will be order of n. So now the only question arises is how we will maintain this left hash map and right hash map. So for that, what we can do is, let me copy this again. So initially, left hash map will be empty and right hash map will contain the frequency map of all the elements from index 1 to the last. So if I just quickly write it, it will be 1 is present one time, 4 is present three times, 3 is present once, 2 is present also once, and then 6 is present twice. So this will be the right hash map so far. And the left hash map will be empty. Also, since we want the triplets I, j, and k, we have I less than j less than k. So it is sure that the center value j can never be one of the extreme indexes. So j will lie only in the middle range. So that's why first we'll iterate on the middle. We'll iterate from this till this part, from index 1 to index n minus 2. So first we'll start at this index. So this means currently my j is here and the value of j is 1. So I need to find in the left part how many occurrences of 2 is present, and in the right part how many occurrences of 2 is present. But when we are at j, we see that left is a 6, but in the left hash map, the 6 is not yet added. So before we do any processing, first we will add the 6 in our hash map. I mean the previous value, which is nums of j minus 1. So we'll add 6 in our hash map. So key is 6, frequency is 1. Also, since previously the right contained all the information of these elements, but we should exclude this element, because when the j is here, the k will be only from j plus 1 to the last. So k cannot be from this element. So we have to delete this one from the hash map. So since one frequency is already 1, we will subtract the frequency, so it will become 0. And since the frequency is 0, we can safely delete the key. So now the hash maps are true, because left side there's only 6 and the right side, this is the information of the right hash map. So now the current element is 1 and the target is 2. We need to find 2 both in the left part and the right part. So in the left part, the occurrences of 2 is 0, and in the right part, the occurrences of 2 is 1. So if we multiply 0 into 1, we get the answer as 0. That means with j as the center, we can't form any triplets. So then we just move to the next index. So 1 is processed. So we'll move to the next index, which is 4. Now again, once you're at 4, you need to add the previous element to the left hash map. So I'll add 1 to my hash map. And the current element I have to reduce from the right hash map. So 4's frequency was 3, now it will be 2. So current element is 4, my target is 8. So I'll search 8 in the left part, which is this left hash map, and I'll try to search 8 in the right part. So both occurrences are 0, so we can't form any triplets. Let's move on to the next index, which is 3. So I think here we'll form a triplet. So let's see how that happens. So once we move at 3, our first step is to add the previous element in our left hash map. So 4 is the key and value is the 1. And the 3 we have to subtract from the right hash map. So 3's frequency was 1, now it will be 0. And since the frequency is 0, we can safely delete it. Now the current element is 3, so my target is 6. So in the left part, I need to find the frequency of 6. So from the hash map, we can directly get the frequency, which is 1. And from the right part, you can see the frequency of 6 is 2. We can get it directly from the hash map. So if we multiply 1 into 2, we get 2. So that means with this 3 as the center, as the j, we can form 2 triplets. So this is the first triplet, and this is the second triplet. So in our answer, currently we have 2. And then we'll move to the next index. Now again the process repeats. We are at 2, so we will add 3 to our hash map, and we will delete the 2 from the right hash map. 2's frequency was 1, now it will become 0, and we delete it. Okay, now the current value is 2, so 2 into 2 is 4. So we need to find 4 in the left part and the right part. In the left part, 4 is present 1 time, and in the right part, 4 is present 2 times. So total triplets is 1 into 2, which is 2. So in our answer, it will now be 4. Now let's move to the next index. So j is at 6. So we are at the new index. So the previous index, we have to add it in our left hash map. So 2. And the current index, we have to subtract from the right hash map. So 6 frequency was 2. Now it will become 1. And the process repeats. So 6 into 2 is 12. So 12 is not present in the left half and 12 is also not present in the right half. So no triplets formed. Now let's move to the next index, 4. So before 4, we need to add 6 in this. So 6 frequency was 1. Now it will be incremented. So it will become 2. And we have to subtract this 4 frequency. So previously it was 2. Now it will become 1. And 4 into 4 is 8. And 8 is not present in the left half. 8 is also not present in the right half. So nothing happens. And similarly, we'll just keep moving forward. So j moves here and we add 4 here, subtract 6 from here and check. And finally, we stop because j stops here because j can't move to the last index. Why? Because for this j, you can find I from the left half, but for the k, you don't have any elements. So that's why we iterate j only in this part. And at the end, when you get the answer, just take modulo with this number and return. Now let's code the approach. So first, let me take two hash maps for the left and the right part. So same thing, we can duplicate to have it for the right map. And n is length, that is 0. Let's take the answer as long. At the end, we'll just take the mod. So our first step is to fill the right hash map. So for the right map, we will iterate from index 1 to the end of the array and just add it in our map. So I starts from 1, I less than n. So 8. Current number is nums of I and the frequency is 1. So for the first time, this is the key and this is the value. But eventually, if you want to add it for the next time, you have to increment the frequency. So for that, what we do is first we get the frequency of this is right map plus 1. So whatever the frequency was previously, to that we'll add a 1 and we'll put it back in our nums of I key. Also here, when we do it for the first time, right map dot get nums of j, nums of I is not present in the hash map. So for that, we need to use get or default nums of I comma 0. So for the first time, if nums of I key is not present in the hash map, then this value will be 0. And to 0, we are adding a 1 and inserting in our map. And after that, this will be present. So we'll get the frequency, add a 1 and again increment it. So this is the process to increment, count the frequency of all the elements. So the right part is done. Now let's iterate on the array. Like we discussed, we'll iterate only on this part of the array. So we'll start from I equal to 1, I less than n minus 1. So first thing, we have to add nums of I minus 1 to our left hash map. So I can just use this and change it to left map. Nums of I minus 1. So that means I am at this index, and before processing it, I need to add the previous element to our left hash map. And also, like we discussed, we have to delete the current element from the right hash map. So for deleting as well, we can use the same thing. But instead of +1, we'll just put a -1. And just to check, if getMap.get nums of I is equal to 0, then we can safely delete the key. I think to have a better clarity, we can use a variable j to iterate on the number because this is the middle element. Let me quickly change everything to j. Okay, so once this is done, now we want the target. target will be 2 times of nums of j. Now to get the number of triplets, we just need to count how many times it is present in the left map and how many times this target is present in the right map, and we need to multiply. So even if it's not present in one of the left map or right map, then the triplets are 0. So we'll just make sure that it is first present in both of the hash maps. So if left map dot contains key target and right map dot contains key target. So if the target is present in the both left map and the right map, then we can safely add it in our answer. Answer equal to, we multiply both of them. So left map dot get target into right map dot get target. And at the end, we just return the answer. Also, before returning the answer, we need to take modulo with this number 10 power 9 plus 7. 2, 3, 4, 7. 10 power 9 plus 7. And since the return type of the function is int, so before returning, we'll just typecast it to int. Test it. Okay. Right map dot get equal to should be outside the bracket. Okay, test is passing. Let's submit. Okay, so if you see the constraints, since the array size is up to 10 power 5, so if you see this line 17, we are multiplying left map frequency and the right map frequency. So in the hash map, both the values are integer. So this is like doing integer into integer. So this value can overflow and we will get a garbage value. So to prevent that, we can typecast one of it to long. So by doing this, the multiplication will happen in long and the value will not overflow. So I think now it should pass. Yeah. Finally, let's do the time and space complexity analysis. So for the time complexity, first we are running a loop to fill the right map. So this will be order of n. And after that, we are again running a loop which will run n times. And inside the loop, we are just getting the elements from the map and also putting updating the elements in the map, which is all constant operation. So the complexity of this loop is order of n as well. So total, the complexity will be order of n. Now coming to the space complexity, since we have declared two maps, left map and right map, and their size can be at most n. So the space also will be order of n. I also have the code in Python if anyone wants to view it. I'll add this in the description as well. And let's catch up in the next video.